the memo of 1 and 2. Alright, so this was your first task for this term. And I gave you the screen and then I asked you to do the buttons. So first one, yes. So let's go on. So let's start with this, the random length. If we open it, the question was generate a random whole 2-digit number. So it's a whole number. So we go integer, 2-digit. So the lowest is 10. Who can see a mistake here for us? Who can see a mistake in this area here? Yes. Highest minus lowest plus 1 and then plus lowest on the outside. And then we display it. So just remember that piece. Then we go to our random breadth. Breadth is generate a random even whole number between 5 and make this bigger. Between 5 and 50. Alright, so then we set random 25 minus 3 plus 1 and then plus 3 on the outside, and then there's a times 2. Everybody happy with that? Yes, so this is correct. Some of you might say, ish, so 3, if we times it by 2, it's going to go to 6 and the lowest should be 5. But remember, we said even number. So the lowest even number, 5, isn't even. So 6 is actually the lowest even number that we can get. So that's why 6 is perfect. So we halved this and we times it by 2. And alright. Then rectangle area, we get the length, we get the breadth, we times them to each other, give it to a variable, and then we display that variable. So that's perfect. That's our rectangle area. That's good. Now we go a random diameter. So with this one, we want a random real number between 15 and 55. So we go random 55 minus 15 plus 1 plus 15 outside. So that's perfect. And then you need to plus the random with the empty brackets. This gives us our fraction. And then we can display it. So that's also perfect. Some of you asked me, can you round it off to make it look better? And then I said it's fine. So if you round it, it's fine. If you didn't, that's also fine. Because the question didn't ask you to round off. Generally in a test, if the question didn't ask to round, then don't. But because this was a project, it was fine. I was open for change. So next one, area of a circle. When we go there, we extract the diameter. Then that is the diameter. So remember, diameter is half the radius. So you take your diameter and you divide by 2. And that is your radius. Then the question was, it's pi times radius squared. So you say pi times, and then you can go radius times radius. This is perfect. Or if you do square of radius, that would have also been fine. Or you could have done power with radius 2, which is also fine. Say again. Yes. So the square function SQR would have worked. And then there's a power function as well, where you could have done this to the power of 2, which is also fine. So whichever one is fine. Then we go to our next one, our random percentage. So display a random whole number percentage. So a percentage though is between 100 and actually 0. You can get a 0. It is possible. I know you don't want to, but it is possible to get 0. So we want the lowest number should be a 0, highest number is 100. Get our random number, we display it. So that's our highest percentage. And then our symbol. You have to start somewhere. In the last program, in your number 3, what I did, I just shuffled the ranges a bit. I said, if I can use this example, I said if it's more than 80, more than 79, show an A. And then I said, if it's less than 69, say a C. Otherwise, if it's in between, say B. So what you do is you just shuffle them. You must always start at one spot and move down. So in this case, extract the percentage. And then if it's more than 79, say A. And then you go else if. That means, remember, this will only happen if this is not true. That means it is smaller than 80. But then if it's bigger than 69, say B. And this else if means if both of these two are wrong. That means it is smaller than 70, but bigger than 59. So that must give us C. And then you just carry on, carry on, carry on. The comment I made here was if it's more than 29, say an F. But if it's less than 29, say G. So what's going to happen if the person actually got 29? Do you agree? Then it's like in the middle because it's none of them. So the exact number 29 is not there. So easy way would have been just to say smaller than or equal to. But another nice thing is with the last one, just say else. So if it's not one of them, do this. So this will cover then all other possibilities. So I would have gone that route. Rather just say else there at the bottom. And that will cover all other possibilities. Alright, then let's look at biggest. So we get the two numbers. And then if the first one is bigger than the second one, say number 1. Otherwise, say number 2. So this is fine. The only thing that we could have maybe, but I didn't, it wasn't in my question. But the only thing you could have maybe faulted with this is if they were equal to each other, you would have said the second one is bigger. So, yeah. So, but I didn't ask, so this is fine. I wouldn't penalize for it. And then our lowest, same thing. Extract the two numbers. If number 1 is less than 2, show number 1. Otherwise, show number 2. So that's perfect. And then is the sum even? So you get the two numbers and then you add them together because get number 1 and 2 and then add them together. So we add them together. And then I ask, is that answer even? So you take the sum, if the sum divided by 2, but the remainder is 0. Remember, mod divides it and then gives the remainder. So if we divide it by 2 and the remainder is 0, then we say yes, otherwise we say no. So this is how we check for even and odd numbers. So please remember this. This is critical. You do need to know this. Good. And then last one, lotto numbers. So we wanted lotto numbers, 5 of them between 1 and 48. So our random number should be between 1 and 48. You wanted 5 of them. So you wanted 5 of them. And then we wanted to display them next to each other. So to get that to happen, we needed to create a display variable and just start it with empty brackets. And then the display should become whatever display was, plus a space, plus then our new number. So that will add the new numbers to display the whole time. And doing the display inside would work perfectly. However, the better place is to just do it outside of the for loop. Because do you agree, how many times do we actually want to display? We only want to display once. All 5 numbers next to each other, but just once. So this builds the display. This is also a key skill that you need to learn and remember. In that when you want to put a lot of things next to each other, create a string variable and then say the variable must be equal to whatever the variable was plus the value you want to add. And that will add the one and then the next and then the next. and then that should work perfect. So if we run our program to just test it, random length, random breadth, rectangle area, diameter, circle, percentage, symbol, we type in numbers here, 12 and 22. Biggest is 22, smallest is 12. Is it even? Yes, the sum is even. Lotto numbers, and there you can see your 5 lotto numbers separated by space next to each other. And that is our first program. So we must just remember, so frac just gives the fraction, and then modern div, they're friends that only work with integers. And how it works, if we've got a number 23 and we div it by 5, then you basically on your calculator, you'll say, what is 23 divided by 5? And the answer would be, okay, let's quickly just see. So if we did it, let's say we said 23 divided by 5. What would be 23 divided by 5? 4,6 hopefully. So now if you go 23 div 5, that would only give you a 4. So it basically throws away the fraction. And then what 23 mod 5 does, so it divides by 5 to get a 4, and now it sees what got lost. So 4 times 5 is 20, so do you agree that 3 got lost? So that one's answer is actually 3. So they work together, I want to say, to get the original number. Because 5 times 4 is the 20, and then that's the 3. So that gives us 23. So another example would be, let's say we say 16 divided by 3. What would that give me? Okay, 5,333. All right. So now, tell me, what do you think when we go 16 div 3? What would that give me? 5. Perfect. So now you reverse it. 5 times 3 is 15. So if I go 16 mod 3 now, what will I get? So remember, this is, yes, it's 1. It's the number that got lost. 3 times 5 is 15, but the number was 16. So 1 got lost. So, yeah. Yes, because you agree, if you take 16 divided by 2, it would be 8 and nothing is lost. If you take 10 divided by 2, it's 5, nothing is lost. So all of them, all even numbers, divided by 2 will always give you no remainders, and that's why it's even. But if it's an odd number, like 5 divided by 2, there'll be a remainder of 1. So that's why that's an odd number, because there will be a remainder. All odd numbers, when you divide by 2, will always have a fraction, and that's why it's no. We got it. Perfect. No problem. All right. All right. So this is the second one I gave you. Um, let's look at this button. Okay. So with this one. So in the question paper, I gave you these 5 things, and I said the VO2 max one, you must now calculate using those formulas. So this person created all of these variables, which is perfect. We don't know. All right. Then step 1 would be extract all of them. All of them would be numbers, except our time is float, and our body weight is float, and our heart rate is float. But gender is an integer, and age is an integer. So we got that from the question paper as well. Now we just have to apply the formula. So here's our formula. So it said that the body weight must be timed by 0,0769. So our body weight times 0,069, and then we subtract that from the 132. So that was that first bit. So that was done perfectly. Then the age must be multiplied by this 0,3877, and that should be subtracted. So age must be multiplied by that, and it should be subtracted from the previous value, which is perfect. Then the gender should be multiplied by that and added. So the gender is multiplied by that and added to the sum, which is perfect. Then the time should be multiplied with that and subtracted. So the time is multiplied by that and subtracted. And then the heart rate must be multiplied by that and subtracted. So then the heart rate is multiplied by that and subtracted. So this is perfect for what that formula asked for. This is it's a long way of doing it. You could have done it all in one line as well. You could have had, by just putting just this, you put that there, and you put that there. So you literally just, exactly like the formula was in the paper. You just type it in here all in one line. And then that would have also given you same answer, and then you didn't need all the variables. So then you didn't need any of these ones. So it doesn't matter which one you like actually. It's exactly the same. It does exactly the same thing. So you could, if you did it in separate lines like this, it's easier to understand and easy to read. If you just did it, sometimes it's easy to just do it in the same line, because now you can just follow from this. You literally take it like it's there, and you just retype it exactly all in one line. And that's perfect. Then the question did ask though that, just go down, to enter the 5 values, and then the answer should be rounded off to 2 decimal places. So if you wanted to use the round function, you needed to times by 100 first, then round it, then divide by 100, and then you can display it. There are other ways. I think Owetu found another way of rounding it off with formatted output, which is also fine. It's something I didn't teach you guys. I'll probably teach you that next year when we work with currencies and stuff. But yeah, and that sort of answers your question as well, Javesh, when you asked, can you do the different thing that's easier? And you guys are more than welcome to use different methods. As long as it works, it's fine. You'll be surprised. Time's running out. All right, our next one. So that's the VO2 max. Now we've got that. Then we need to do the rating. So the question asked us to do the rating according to these levels. There was a gap there between 51,1 and 51,8. Yeah, so sorry about that. Generally that won't happen. They will line up nicely. There's not supposed to be gaps in between. They're supposed to, as the one enters, it should go into the next one. There's not supposed to be gaps in between. So I'm sorry about that. But yeah, when you get a proper paper, it won't be like that. So first of all, extract your VO2 max and just take, if it's less than 38, say low. Then if it's less than 42, so basically between 38 and 42, we're going to say fair. And then if it's between 42 and 50, we're going to say average. And then if it's between 50 and 55, good. And between 55 and 57, actually above 57, we're going to say excellent. So this one, I'll be very lenient when I mark it, because I know that the ranges in the question paper was dodgy. But the idea is right with this one. Then we went to the name where the name is typed in, and then I asked that we should ask the user for his name, then display the code. The code is the first letter of his name, then a random letter from his name, and then the last letter of his name. So when we do our code, step 1 is get the name. Then we want the first letter of his name, which is good. Then we wanted a random letter. So you didn't need to extract it again. It was already extracted. So we don't need that. We don't need to do it here either. But then what you can do is, so we get the length of the word, and then we get a random position where we use random. The highest is the length of the word, lowest is 1, plus 1 plus 1, 4 plus 1 and then plus lowest. And then we extract the character at that position, which is perfect because we can't get a random character, but we can get a random position within the length and then extract the character at that position. So that's perfect. And then we just wanted the last character. So again, get the length, which we already did, so we didn't need to do that again. Remember, if you already put it into a variable, you don't need to do it again, so we can just use it again. So for the last character, it's just sentence at position now, at that last position. Put them next to each other, and that's our code. So that's perfect, I'm happy with that. And our last one was the position of an A, but then if there wasn't an A, then we must show the position of the E. So with that one, extract the name, get the position of the A. Okay, then this person displayed it, which is okay. But then if find is 0, meaning it didn't find the position of the A, then we didn't need to extract it again. But then we look for the position of the E inside sen, and then we display that one. So that's perfect. I'm happy with that. See, so if it didn't find the A, it would have displayed a 0, but then it would have looked for the E and then displayed the right value. So that's perfect.